Hello, everyone.
Hello. Welcome.
Hey, Rob. Nice to have you back this week.
Yeah, nice to be back and nice to see you. Actually, be on with you because usually it's either or it's me and Carl, or it's just Carl, or it's just you, and it's like we're going back and forth with this. So it's nice to be here with you.
Finally, our paths have crossed again, which is good.
Absolutely.
Cool. So what I'm going to do first is bring up the code of conduct and just read through this quick. So in today's session, we ask that everyone is aware of others, friendly and patient, welcoming and respectful, open to all questions and viewpoints, understanding of differences, and kind and considerate to others. So with that out of the way, Rob, do you want to introduce who we got on the show today?
Well, yeah, sure. Today we're going to have on someone that I personally met a couple of times, and she's a really, really lovely individual, and do a lot with the community things here in Oslo. So unlike most people that I kind of interact with, I actually get to see her from time to time, and newly crowned MVP. So we welcome her to the club, and it's Kristina Devochko. Hey, Kristina.
Hello. Well, this was a lovely introduction. Thank you, Robert.
It's so much better background than me. I really need to start doing something with my background, but I only have like a couple of weird stuff. But you have a lot of things going on there.
It looks so
Yeah.
Yeah.
So you can use time to kind of look into those things instead of listening to my presentation and what I have to say.
I think that's one of the reasons why a lot of people who are doing this talk have a lot of things in the background. So if people start spacing out, at least they're looking at something,
Yeah, but, you had a dog in the background though for not that long back, so maybe
she might come back up again. She's tired apparently. So.
Oh,
nice.
Yeah, Kristina. So what are you going to talk about today?
So today I would like to talk about AKS. I have been working with AKS for a while now, and I would like today to share my journey with it and also the journey of the projects that I have been working with where we were adopting AKS. And this session will kind of be a story based, if you've seen the series Tales from the Crypt, so it will be kind of like that, just less scary, but more about
hopefully less scary.
Well, it is Kubernetes, so
it's less scary now. When I look back, it probably was a bit more scarier for us then.
Scary for some, but not for us.
Until we master it.
Yeah. No.
Or do we ever master it?
I don't know.
Probably not.
Well,
no.
Probably not. Yeah. No. All right. Cool, Kristina. You just go ahead. We're taking questions as always, and if need be, we're gonna jump back in and talk a little bit. So
awesome.
Sounds awesome.
Right. Awesome.
See you in a bit.
All right. Cool. Thank you so much. Then let's kick it off. So. As I said, there was a great introduction from Rob, so I will not use so much time on that, but just a few more words about me. I am working as a software architect and I'm based in Oslo in Norway. And apart from my work, I also love contributing back to the tech community. And recently I have started contributing as a speaker, so I'm really excited for this session. It's the first time I'm presenting it kind of externally in the community, so I hope you will find something useful for yourself in it. And in my free time, I love reading and watching Harry Potter. It's never enough, though I've watched it a million times. And I like going on hikes, do puzzles, and play retro games. So if you do not recognize the game on the right bottom hand side here, it's probably not a problem. It's called Keo the Kangaroo, and it's really retro. I think it's from 2000, and I still play it when I get time. It kind of really fell into my heart, so I like sticking to the classics. But enough about me. Let's start with the most exciting topic of today, and it is AKS and what you should think about and be aware of before going all in with it. And I would like this to be a story-based, entertaining session where I can share the learnings and the mistakes that I have been through when we started adopting AKS in one of the projects, and we actually in one of the projects had to stop rolling out our applications in production in AKS. We had to roll back, get back to the table, and reiterate and make improvements in order to be able to run it in a stable way long term in production. So I hope that this session today can also help you be more aware about it, and when you decide to adopt AKS or hear from your boss or your customers or your users if you should adopt AKS, you would be more aware of what it really takes to start working with it. And once we hear about managed Kubernetes service, we may get a lot of questions that some of you may have heard before, like if it's managed service, doesn't cloud provider just take responsibilities for most of it? So with AKS, doesn't Microsoft just pre-configure, secure, continuously update those AKS clusters for me, and I just need to do the bare minimum, maybe just take my applications as they are and package them in a container, and I get all this self-healing and auto-scaling and all those goodies out of the box, and it works perfectly? Well, I think we just need to say that the real answer is no. It is not that easy as it seems in reality, and there are many details that you should be aware of that will require you to handle, which Microsoft will not do for you. So the hard fact is that AKS is not a platform as a service offering, and this is actually something that is also stated in official Microsoft documentation. I thought it was for a while, and you can still find articles and blog posts where it is called a PaaS offering, but in reality, it is not. And even though Microsoft manages some AKS components like control plane, there are still many parts of AKS ecosystem that are a shared responsibility, which means that you need to take care of it because Microsoft will not. And we hear a lot about Kubernetes being hard, but what about managed Kubernetes services like AKS? Is learning it hard? And from my own experience, from experience of the others that I know that have been working with it, you still need to understand how Kubernetes works, to understand Kubernetes foundation, how control plane works, how it hangs together with worker nodes, how you upgrade and secure it. And it is a steep learning curve. And the development of Kubernetes and even releases of AKS happening multiple times a month even, it requires you to continuously learn, and it requires a lot of time and dedication from you because you need to always stay up to date. And I also like Richard often says, which I fully agree with, that you actually can never become 100% expert by reading so many books and so many courses. You need to continuously learn. It never ends. So you should be prepared for that. And we hear a lot about day 2, the operations day when you have the applications up and running in AKS in production, and then you start operating it. But today I would like to also put a huge focus on day 0, on design and architectural phase, because it is so crucial if you want to succeed with migration to AKS, and you need to invest and dedicate time and effort into this phase, and do it in layers where you work and plan all the different layers of your technical platform on AKS, with networking, security, architecture of your applications in mind. So if we will try to break it a bit down, what should you think about before going all in with AKS? And I have a lot to share, and we don't have much time. So some of these points that I'll touch upon briefly, because they do not necessarily relate to AKS exclusively, but to Kubernetes and containers in general. And some of them which are more interesting in terms of AKS, we'll take a look at in more detail. So bear with me here. So the first point that I think is really important to mention, and which I believe also comes first, is the readiness of your applications to be running in containers on AKS. And this, from my experience, I believe that this should be step 0 of your journey. You need to use time to evaluate the current state of the architecture of your applications and see if they are ready to be run in containers and to be run on Kubernetes and on AKS. And you need to evaluate what kind of applications you have. If you have microservices, if you have monolithic applications, if it's a single application or multiple, if those are multi-tenant or single tenant, if they need to store state or they are stateless, because if they need to store state, you need to think about how are you going to persist the data, because containers, they are ephemeral, so they can die at any moment. So you need to store that data outside of your application containers, and there you need to evaluate if it should be services like databases and storage, if they should be hosted inside your AKS clusters or outside. And both approaches have pros and cons, but you need to think about it for your specific use case. And in, for instance, one of the projects that I was working with, we have a single tenant application with 400 tenants. So migrating a 400 tenants application to AKS with, in addition to multi-tenant services running side by side with that application that are common and shared, it requires a totally different level of complexity, scale, and planning for your technical platform, for your AKS clusters, than if you would migrate a few microservices that are multi-tenant. So you need to think about all these aspects. And another important point is that if you have a monolithic application, of course, you can package it into a container, you can put it out there on an AKS cluster, but it is not given that it will be a cheap, scalable solution that will give you that faster time to market by default. And I had to learn it also the hard way, even with all the planning. And the important point here is the image size, because the image size consists of multiple components. So when you package your application in a container, you have the base image, and you have the patching and security updates that come on top of it, and then you have the application itself. So if we take a .NET Framework 4.8 Windows base image as an example, it has 5 to 6 GB in size, the base image itself, and then you have a few GBs of updates, and then you have an application on top of it. So when we were working with such a monolithic application and we created our first container image, it was around 13 to 14 gigabytes in size, and just pulling that image from a container registry will make the scaling a bit challenging to have happening fast. And if you put the warm-up time that your application requires on top of it, if you have a lot of configuration and preparations you need to do, it adds up all those minutes for your application to be ready. And you can imagine that if you need to scale fast, if you need to scale out, then you might have a problem. So you need to consider that and attempt to make your applications lightweight. And there is a reason for why we hear that microservices are more well suited for Kubernetes, for AKS, for containers. And if you see in the bottom here, there is a screenshot of one of the success stories from Forza Horizon, which is a racing application which succeeded running their all their system on AKS on Windows containers. But once you read about it, you see that this is because they have 17 microservices that they are hosting, and they are relatively lightweight, and they are also using managed services from Microsoft that, like for instance, Azure Cache for Redis, which are highly scalable services where Microsoft takes a responsibility in kind of managing it and making it highly scalable. So the combination of all this details made them succeed. So it is not given that there is a one solution that fits all. So you need to look into your use case and your apps, but it's important to consider if you need to refactor. And you also need to consider the general strategy. If you are dedicated to a single cloud provider, if it's only Azure, or if you have a multi-cloud solution, or if you have on-premises Kubernetes clusters also running, because then you can also look into Azure Arc, which kind of helps you manage and unify all the different Kubernetes workloads that you have running and make the management and administration of that easier. And of course, you should consider the new and hot Azure Container Apps, which takes it a bit over, abstracts the Kubernetes, the AKS from you, and offers a serverless solution to you. But it also has its caveats. So if you need to, if you're dependent on Windows containers, or if you need to access to Kubernetes APIs, or for instance, customize or have access to custom resource definitions, then you can't do that with Azure Container Apps. But it is an opportunity. If you have just one or two microservices, it will be an overkill, most likely, to have an AKS cluster in terms of how much effort it would require. So you can then consider Azure Container Apps. Another point that we will touch really briefly upon is organization readiness, though it's a really important one. And here I would just like to quote Kubernetes, because I think they said it really well. Kubernetes management requires making cultural shifts on steroids. So once you decide to adopt AKS, you should do it for the right reasons, and not because Spotify or Uber does it, or because it's cool and I want to work with it, or because we'll be able to recruit more developers because we have these cool technologies. No, you should adopt it for the right reasons, because it requires so much from you and your organization, and you should do it if it brings value to your organization and your customers. And of course, this must be aligned. This decision, this technical roadmap needs to be aligned across departments. And I can't stress it enough, because it is also from my own experience. It's not given that you demo all this cool stuff in AKS and you tell about all those AKS benefits and it looks really cool and people nod, developers nod, operations team nods. It's not given that they actually understand what it will require from them. So you will need to work tightly across departments to make them really aware and understand what it will require from you. And it's not given that you will get that profit out of the box in the short term, but it may actually be in the long term. And collaboration here will be the key. And also you need to account for the time you need to learn, because not that many organizations may have skilled Kubernetes administrators, for instance. You may be learning this by yourself, and then it takes much longer time and to master it, to work with AKS efficiently. So you need to think about that, and you need to have time to experiment. Since it's being actively developed, AKS is being actively developed, you need time to experiment, try out new features, fail, learn from it, see the ways to improve and simplify your technical platform. So you should also include that time in the planning of your technical roadmap. And a very important point, one more important point that you may also see a lot of memes about out there, is that you need to think about developers. And if there are any developers here today, I am a developer myself, you know how developers in real life actually are. They want to code in peace, they love being in their cozy comfort zone, and they don't necessarily like to learn new tools that they will not need to use on a daily basis. They just want to sit there, bring value to the applications that they are developing. And the rest, when in terms of deployment, CI/CD, security checks, it should all be easy and come out of the box for them, because they don't have time or effort to kind of put themselves out there and maybe learn it or maybe work with it from time to time. So you need to make this transition, this new technical platform, easy for them. And there are multiple ways you would do that, but the goal is to reduce cognitive load on your developers, to simplify it. And for instance, the way we did it is that we started using .NET custom templates. So this is kind of an easy way to package the kind of the skeleton, the blueprint of a microservice, for example. It can be whatever application, .NET application, React app, whatever. But what it helped us achieve is that the developers can just install the template, and it creates all the folder structure for them, the Docker file, the build pipeline with all the necessary stages, security checks. It installs creates or generates a Helm chart, and what they will only need to do then is to add the application code and adjust the configuration of that application for it to be deployed in AKS. So it makes their life a bit easier, and especially in the beginning, it helps them adjust and helps them to spare time when they need to get that application out there on AKS. And one more experience that I have seen a huge benefit from is actually not just demo yourself, not just talk about it being cool, but actually engage your operations team, those who will be operating those AKS clusters, your developers, engage them in hands-on sessions. So let everyone create their namespaces and deploy a WordPress application to that namespace. Let them learn together with you, follow along during a live session. And if things fail, perfect, because then they will see how you think when you debug issues in the cluster. And that's what I have seen so far. This is when I got the best feedback, the most engagement, and the understanding, the real understanding of why this is beneficial, why containers and why AKS is beneficial. So this is this, I believe, is the way, helping them to get that hands-on experience while you guide them is really of huge value, especially early on. Oh, and one more thing, of course, is that if you want to ensure that best practices are followed, you should not just expect developers to remember that. You should have automated checks in place that can help you check those practices automatically and fail the deployment if it is being violated. And we will actually see how you can do that later on. And one more important point is configuring dev clusters versus configuring production AKS clusters. And of course, it is not the same, because in dev, you may typically have shortcuts, have workarounds. You may need to not use all the functionality that is out there to save costs, but you you can't take that risk in production. So you need to think about those differences and how you can avoid testing in production, but have some kind of strategy on how you can simplify and ensure that the production clusters that you have are actually configured according to the best practices and are really ready for you to get your users and customers onto those clusters. And it takes time to build production ready AKS clusters, so you need to include that cost in your roadmap. And once again, I can't stress this enough. Your operations team or those who will be administering your AKS clusters, you need to involve them early on. It's not enough that you develop and create those clusters and how those work, but you need to involve your operations team, because they will be the ones taking over once it is out there in production. And the way we did it in one of the projects is that in development, we have one cluster, which is Playground. It's very simple. We easily configured, and it is meant to fail. So you can go there, experiment, prototype, test out new stuff, and see how it works. And then we also have a cluster that is as similar to production as possible, so that if we introduce some new functionality, if we introduce new policies, for instance, with Azure policy, we can test it out, and we then have more confidence and security that once this is enabled in production, it will not cause disruptions and downtime. And then your operations team can actually train and get hands-on in development with development AKS clusters first. Learn how to upgrade those, learn how to enable policies, debug and monitor, and then they will also feel more confident to do the same on the production AKS clusters. So there is some good documentation out there about AKS, called AKS Baseline and AKS Landing Zone Accelerator. So I have some resources in the end of this session that you could reference for a more detailed research on that. And here is an example from our own AKS cluster, something that still gives me nightmares from time to time. What you can see here, it's blurry, but it's not that important. Here you can see another best practice that you should learn from the beginning, which is setting those resource limits on your deployment. If you don't set the resource limits, how much CPU, how much memory your applications are allowed to use, you may end up in the situation like this, where you have here we have two applications that sneaked their way into an AKS cluster without any resource limits set, and it took other applications down and caused a full havoc in that cluster, where you can see a lot of pods being evicted, a lot of pods being terminated. You can even see crash loop backoffs and out of memory states, which is a really, really scary thing. So do not underestimate those resource limits and set them and have some checks to ensure that they are set, because you would not want to try to clean that up afterwards. So for every demo, there will be a GIF-cat. So let's see it in real life. What happens if you actually don't set some of these best practices in place for your applications. So let's take a look at what happens if you don't set health probes. So here I have a mission critical application. I have a cat encyclopedia that gives all the users a cat fact of the day and a cat image, and then all the cat enthusiasts can spread some more love by clicking on this button here. And they really need access to that one ad hoc if they need some cat love, fill up, pick me up. So it's really important that it's up and running. But what happens if I actually try to upgrade it to a new version where I don't set the health probes? So for this purpose, I have created, let's see if I can just have this screen here. I have created a faulty version of this application. that will simulate an error. So this is a .NET 6 web app, and what I did is that I used a base image that uses .NET 7. So we can simulate the error where the application will actually be deployed, but when you try to start it, when you try to do some requests, it will actually fail. And we are skipping the whole CI/CD process here because we don't have enough time for that. So I will just use a Helm chart that I have packaged locally. So what we can do is that we can take a look at how our application looks right now. So I will just get the pods in namespace cat encyclopedia. And I have a one pod that is up and running right now. And if we also take a Helm list, we can see that it is up and running with version 0.0.1. So let's try to update it, to upgrade it to a faulty version. So I will just use my cheat sheet to spare some time. So what we will do is that we will take a Helm upgrade to a version 0.3, which does not have the health probes set. We can actually take a quick look at it, since Helm is basically a compressed folder of the deployment templates. If we open deployment YAML for this version, we can actually see that the liveness and the readiness probes are commented out. So what will happen now if I run this command? Let's do it. And then we can see what happens in real time with -w. So what, let's see here. Just give me 1 minute. I might be. This is the demo gods problem. Did I use the wrong Helm upgrade? Kerens. All right. We were actually okay. Let's see. I need to look into the time here. This was a bit unfortunate. Let's see if we can do a shortcut here so that I can simulate it. Let's use this revision here. Oops. Sorry about that. So let's do a small workaround here so that we can simulate it. Let's use revision 9. So if we try to see once again what happens. Oh, all right. Okay. That is so typical. I'm so sorry about that. Let's just okay, let's I will skip this one then, because we don't have so much time and I need to think fast. But typically, if you don't have a resource, if you don't have health probes set for your application, what will happen then is that it will terminate the currently active pod, because there are no checks that the application is up and running, and then it will just mark it as healthy and just perform the upgrade, and this will actually cause the downtime. But as we have seen now, if you have the health probes set, then you will see that it does not, that Kubernetes cluster will actually be able to detect that the new version is crashing, is not healthy, and then it will not terminate the existing version that is currently active and is up and running. And in that case, you will not have any downtime. Your app will still work, and at the same time, you can work on those issues inside your application and attempt to deploy next time when those issues are fixed. But it's not given that your developers will remember about that. So let's just cancel this one, and let's see how we can check these policies automatically. And for that, I would like to show you Azure policy. which is a really great resource that can help you lots on kind of setting those policies. So I have another application that I would like to deploy and into an AKS Hello World namespace. And for that one, I have configured.
Sorry, just me jumping in. We've got a question about liveness probes I wanted to ask before we get too deep into policies. So I'll just bring it up on the screen. It's from Daniel. He wants to know, what is your take on liveness probes?
What is my take? Well, from this is something that we set for our applications in our projects, and it works. It has been working really well, but I know that this you kind of need to see how your what kind of application you have, because I know that there are some combinations that do not work that well. So it's not given that liveness probe is a must for every single application. That's what I can say. So I can say that it depends. But for the applications we have running in our project, we have a combination of liveness and readiness probes, and it has been working pretty well for us.
Awesome. Cool. Right, I'll let you carry on now.
Yeah, thanks. All right. So we have two policies that I have configured that will ensure that the application you attempt to deploy to a specific namespace has both readiness and liveness probes configured and has the resource limits set, those scary and important ones that I've been talking about. And especially with resource limits, we have also defined that those do not exceed the values that we have defined here. And we can also check that for this specific demo, I have only configured these policies to be enforced for a specific namespace, so that we don't cause disruption for the rest of the applications deployed in my AKS cluster. So let's try to deploy it. To deploy this application I have here, so I can just quickly show you the Kubernetes YAML template, the initial one, where we will actually comment out the liveness probes, and we will configure the resource limits, but we will set them to be higher than what the policy requires. So once we do that, let me open it here, we can try to deploy it. Let's clear it here. And for K means kubectl, so I'm just using an alias. So what we will do is that we will deploy this YAML template for this AKS Hello World application, and also deploy an ingress resource in addition, so that we can access it and see if it works. And now everything looks good. So it seems like all the resources should be created, but we can actually check if there are any pods that have been created for us. And what we can see here is that no resources have been created. And the way we can see if what's happening here is that we could get our deployment, which is kind of an abstraction over the collection of pods and represents the deployment of our application, and get it out in a YAML formatted output, because then AKS will get all the information it has for this specific deployment and put it out to the command shell for you. And what we can see here is that we see errors related to gatekeeper, which Azure policy is built upon. And we can see that it says that my application containers, they do not have liveness probe and do not have a readiness probe configured. And this violates the policy we have defined for that namespace. And we can also see that my containers have CPU limit and memory limit that are higher than the maximum allowed. So let's fix that and see if that would help. So let's get back to our deployment YAML and uncomment our health probes, and then also update all the resource limits to be compliant with Azure policy. And now let's force the redeployment here. So for that, I will just use kubectl replace and force. And what will happen now is if we just get deployment, just to see, it says that there are still some pods that are not ready, but let's see if they are actually being created. So let's do the get pods, and we can see that now the pods are actually being created and one is already up and running, which means that our fixes helped and the application is now compliant with the policies we have defined for that specific namespace. So these policies can actually help you avoid even getting this faulty version out there into your cluster. It can actually stop you from provisioning that deployment in the first place, which will also help you to debug issues, to shift left and detect those issues earlier. So if we now go to the public IP of our AKS cluster, we can actually see that we have our app up and running. So do check out the Azure policies. They are extremely useful and can help you lots, but you just need to be aware that it takes time. It takes like 15 to 20 minutes sometimes to synchronize your changes across clusters, for instance, if you're configuring it on a subscription level. So just experiment with it and see how which policies would work for your use case. So let's move on to the deployment strategy, to the next important point. And as Shakespeare might have potentially said at some point, to GitOps or not, and that is the question. And I heard many times before that from others that when you are talking about deployment to Kubernetes, doesn't that mean that you need to use GitOps? And I would answer that it depends. GitOps is the golden standard, of course, when it comes to deploying your applications, performing upgrades of your AKS cluster or Kubernetes clusters in general. But it actually requires you to be prepared in order to succeed with GitOps. You need to have good development processes in place, which are agile, where you have a very good automatic test suite, where you have a good security posture with DevSecOps methodology kind of being the core of it, where you have automatic security controls implemented, where you have good processes on reacting fast, and you have good observability so that you can detect quickly if there are any issues and react upon those. And you also need to have competence because those GitOps tools that you are going to use, they may fail as well. And you need to be to know how to operate those GitOps tools, how to upgrade them, how to fix security vulnerabilities which may pop up, and how to debug if things go wrong. And if you're just beginning this AKS journey, just starting really lightweight, it is totally fine to start without GitOps. We did prototyping of that, and we saw that we were not ready. We had teams that were not ready to deploy applications fast enough. We did not have enough resources to be agile in terms of also administering GitOps tools. So we started without that. And you should focus on getting those skills, getting those hands-on experience with operating AKS clusters first, and then you can migrate to GitOps when you are ready. So the goal should be to build maturity and simplify that technical platform over time. And a very interesting point that we learned the hard way as well is the upgrade strategy for your clusters and your nodes. And doesn't Microsoft do that for us? I thought it did, and I was not alone, but they actually do not. And they do partially, but you need to know what it actually means. And the first point to begin with are pod disruption budgets. If you are, for example, using Helm charts to deploy your applications, this pod disruption budget resource is not created for you when you run helm create command. So you need to explicitly create that resource and know that you need to have it, because pod disruption budgets ensure that once you upgrade the nodes, for instance, the node operating system where your applications are running, then it will ensure that the amount of application replicas that you have defined as part of pod disruption budget will be up and running, and the AKS cluster can take only that many replicas down during upgrade. So it will ensure less disruption to your application and will help you perform upgrades without downtime. So you really need to remember about setting those. And when it comes to upgrading node images, there are differences in how images are patched, for example. So Linux images are being automatically patched with security updates by Microsoft, but you need to remember to reboot, or at least use tools like Qord to detect when the reboot is needed. But for Windows, Microsoft does not perform any updates or patches on Windows node pools for you. So they release a new Windows image version, and you need to ensure that you upgrade your nodes to this newer image. And I think Microsoft releases a new image on a weekly basis. So you need actually to remember to explicitly do that yourself and have routines to do that. And when you need to upgrade your AKS clusters, an important thing to remember is that with newer versions of Kubernetes, API deprecations may come and API removals may come, and you might need to update your templates, your deployment definitions to remove those deprecated and de-supported Kubernetes APIs. And there you should consider tools like, for instance, Pluto, that can automatically scan your resources for you and let you know what exactly you need to update. And also an extremely important part of this upgrade strategy is the Kubernetes, the AKS version, the Kubernetes version policies in AKS. So this is actually very important to remember. And due to the active development of Kubernetes, the older versions or many versions get de-supported pretty frequently. And once the version is de-supported, you are not allowed to create new node pools in AKS, for instance. So if you are running on a de-supported version or in your AKS cluster, you will not be able to create a new node pool if you suddenly need to scale. You can create it on the supported version, but it's not given that it will work, because it may actually require you to upgrade your control plane to the supported version of AKS, which you can imagine when you need to scale suddenly, you have crisis in production potentially. This can be really hard to kind of fix straight away. So be aware of that. And also, if you are laying behind for more than 3 minor versions, Microsoft will reach out to you and gently ask you to upgrade. But if you do not, they actually have the full right to perform the upgrade to a supported version on your behalf if they see the version you're running on as a security risk for them. So you probably wouldn't want Microsoft going that far for your clusters. So it's a good idea to always to have this routine of upgrading, keeping your AKS clusters up to date on a supported version. And there are multiple upgrade strategy possibilities. And we are doing out-of-place upgrade in one of my projects, basically due to the fact that we have an application that is highly critical, and we cannot take the risk of upgrading in place, upgrading the AKS cluster where applications are currently running. We basically spin up a new AKS cluster and migrate. And for that, we have automation framework in place and infrastructure as code that ensures that we can do it efficiently. But in your case, in-place upgrades may work and rolling updates may also work. So you should also evaluate what would work best for you and will be efficient. And another extremely important topic as well is cost, because it is not given that you will be able to save money in the short term by just adopting AKS and adopting containers. And an interesting CNCF report actually shows that for more than half of respondents, the results are that they have seen Kubernetes costs increase. And there may be many reasons for that. So when you decide how you are going to configure your AKS clusters and where, you need to think about how much it will cost for you, because the VM sizes you choose, the region where you will decide to provision your clusters will have a lot to say. And if you have configured auto-scaling and a memory leak or an application bug or missing resource limits come into picture, then you can suddenly scale to many, many nodes in your cluster, which will boost the cost sky high potentially. So it will not help on optimizing your cost. And by default, I think there are 20 nodes that are configured if you enable auto-scaling. So just be careful with that. And have some policies also in place that can ensure that you deploy applications according to best practices. And tools like KubeCost can help you lots with cost management. And my recommendation would be to start using them early on. KubeCost has a really nice integration with Azure, where you can actually also see overview not only of which resources in your AKS clusters use how much and what is the trend and what are the recommendations for you to improve that cost for your AKS cluster. You can also see the overview of other Azure resources that are running externally, so not inside the AKS cluster, but outside of that. And you can kind of get this a wider picture from the same tool. So we were a bit late on using KubeCost, but we got there now and are using it, and it really helps a lot to get a good picture of your costs and cost trends. And there is also a Microsoft Learn module that I would recommend to check out that actually has a few recommendations that can help you to optimize cost, like shutting down your clusters in development, for instance. Like if you have a playground cluster, no need for it to be running during the night. And since the cost is based on Azure VM costs, like a regular Azure VM costs, then you can also use possibilities like reserved instances or spot instances where you can use underutilized resources in Azure. And Azure policy can also help you set a cost budget. And the last point there is actually something I wasn't aware of until recently, but if you have an enterprise agreement, you can actually use dev test subscription instead of pay as you go, because in development, it gives you a reduction for Windows nodes where you can use Windows nodes to the price of Linux nodes from the same VM family. And if you take a look here, there are huge differences. You can have a 50% reduction basically in development for Windows VMs. If you are dependent on Windows containers, this can be a huge benefit in terms of cost. So do check if you could use that. This could help you lots for your dev and test clusters to spare costs, and your boss can be really happy about that. And once you do this, you kind of get this efficient resource utilization by default, which also contributes to sustainable and greener cloud solution, which is really important nowadays as well. Now we are getting closer to kind of the to a few last but really crucial areas. And the first one of those crucial areas that I really love digging into and talk about is security. And we might think that Kubernetes and even AKS is secure by default because Microsoft wants their infrastructure, their services to be secure, but it's actually it's a trap. It's not that. It's not given. You need to do quite some effort to make them secure. And there are some nice reports that have been done where a few companies like Shadow Server and Cybele Research Labs did some threat hunting exercises, and they have seen, as an example, almost 80% of Kubernetes clusters globally, of those Kubernetes API servers being exposed to the public internet. And it's not given that it's a resource issue in itself or a security issue in itself, but it opens up an additional attack surface that can give threat actors a chance to start attacking, exploring, experimenting with it, maybe trying to get some information like Kubernetes version that they should not have access to in the first place. And in AKS, when you create with default configuration, API server is actually exposed by default to the public internet, though anonymous access is disabled but still. So you need to consider and use authorized IP ranges, for example, for access to AKS clusters, have that proper role-based access control, and also consider if creating private AKS clusters where you can only, with a very limited access, if this would work or would be needed for your specific use case. But in general, the goal should be to minimize the attack surface of your AKS clusters and application containers. And one more example is in terms of application container security. For example, an ASP.NET base image is actually requiring you to run. It will run as with a root user, and most of containers that you create will be running with a root user with extremely high privileges, unless you explicitly configure it to use a user with limited privileges. And this can be potentially disastrous. So you need to think about not using a root user when you run your application containers. And for an ASP.NET image, there are workarounds where you need to use a higher port so that Kestrel web server will then be able to use a non-root user. And the newly released .NET image that is with chiseled Ubuntu containers, which is kind of a distro-less alternative of a classic .NET image, can actually be an alternative at some point because it uses a non-root user by default. So you need to think about and analyze the definition for your application containers, and also ensure that you have that security context set for your AKS clusters, because if not, then it will use whatever is defined in the Docker file, and that may be the root user if you have not explicitly set to use another user otherwise. So minimize the defaults, think about least privilege principle, and do analyze the configurations of your containers in addition to the AKS cluster itself. And there are many frameworks that can help you with it, even the Azure Security Baseline for AKS that I will share in the resources afterwards. And the approach to security with containers, with AKS, should be multi-layered, where you need to have automatic security controls at all the stages of your software development lifecycle, because it never stops. You need to continuously improve and continuously update your workloads to ensure that you are always running on the most secure versions and secure configurations. And there are tools like Trivy from Aquasec, Hadolint, Azure Policy that can help you enforce those checks and validations automatically. One more cat and one more quick demo. I know we are getting really close, so I will try to speed up. One more interesting demo that I have prepared for you is where we can see how the name spaces that you create by default do not provide you tenant isolation by default. So this is also a misconception that namespaces give you that tenant isolation without anything else on top of it, but it's actually not completely true. So let's take a look at the pods we have currently running in our AKS cluster. What I have provisioned right now is something called Kubernetes Goat. So check it out also afterwards. I have linked to that one. And what it has is it is a collection of. No, this doesn't look very good. Kubernetes Goat is a collection of vulnerable by design applications that are provisioned to your AKS cluster. So obviously, don't do it in your production. Don't deploy it in production, but in development to kind of play around with it. It could be really nice to learn more about security in AKS and Kubernetes. So what I have provisioned here is that I have a hacker container in a default namespace, which obviously you should not do in production. And I have a Redis deployment that is running in a totally different namespace, ironically called secure middleware. So we'll see if we'll be able to get access and interact with my Redis deployment in that namespace from inside of the hacker container running in a totally different namespace. So let's log in to my hacker container here. Initially, you would need to analyze what the IP range is for your AKS cluster. So I have already done it, so we can skip that, but you can check out the resources afterwards on how you can identify what the IP range is, what are the subnets configured in your AKS cluster. But I have already done it. So what we will do is that we will run a network scan from inside of that hacker container with a tool called ZMap, which is a very simple network scan tool, which is more lightweight and faster than Nmap, for instance. It will scan for this IP range, and if there are any IPs that expose port 6379, which is a default Redis port, and it will output the results to the text file. So this one should be pretty quick because we don't have that much configured and up and running. So let's just give it 3 seconds. And once it's done, we can just get the output here. So we can see this IP that exposes the port 6379. So let's try to connect Redis CLI to that IP. And we are actually inside. So we are running from default namespace. We have connected us to the Redis deployment, which is also ironically not password protected. So let's try to run some Redis commands like ping, like getting the keys that are saved in this Redis instance. And if you have any at some point done capture the flag, let's capture that secure flag, which you can see is Kubernetes Goat. So this is an example of that there is no tenant isolation if you only deploy your applications into different namespaces. So you need to have network policies in place and also have proper authentication and protection of your applications in addition to ensure that there is a proper tenant isolation in place. So I still have a few slides, but Richard, just stop me if I am really running out of time, but I hope it's okay if we take a few more minutes. I have two last points that I would like to share with you. And the first one of the last ones is about preview features and issues, vendor-side issues. So if you have recently seen this one, some of you might recognize that one because that one caused me a bit of sweat in August. And what happened here is that on the 30th of August 2022, Microsoft pushed a system D update to their Ubuntu VMs on version 18.04, which caused outages where AKS service got hit the hardest. So across all the regions, it was affected, with applications going down with DNS resolution errors. And by default, until the version 125, AKS has been using Ubuntu 18.04 as the default node operating system for AKS clusters, unless you explicitly define something else. So some of our applications did go down at that time. And as you know, as we mentioned previously, when we update Linux, when we update Node OS on Linux, Microsoft updates it, but you still need to reboot. So Microsoft did not reboot, but reboot was actually a workaround in this case, because then you would get the fresh DHCP DHCP-lees and DNS resolvers, which would cause your applications to go up again. But we didn't know that until later, when you kind of get more information from Microsoft as well. But this illustrates that even cloud vendors are not 100% up and running at all times. So you need to have that business continuity planning and disaster recovery plans in place, and have subscribed to those Azure Service Health alerts, have that uptime SLA enabled, and continuously test your disaster recovery, your business continuity plans with tabletop functional and full-scale exercises where you can actually simulate outages and test how well prepared you are for that. And documents like Azure Resiliency and best practices for BCP and DA and AKS are really recommended, because you can learn more about multi-region deployments, for instance, and other best practices that can help you to get that in place. And when it comes to preview features, you should probably follow the recommendation to not rely on those in production. And from our experience, we started using Windows containers long before they got GA, and they got GA for not that long ago, in April 2020, if I'm not mistaken. And since we have a pretty heavy application, we have also experienced a lot of challenges with making it stable on Windows containers, because there were missing features, differences in memory consumption on Windows nodes versus Linux nodes, which caused a lot of instability. And you did not have that auto repair feature on Windows nodes to begin with. So it came out after some time after Windows support for Windows nodes reached GA. So be prepared that if you are early adopters of a new feature or of a preview feature, you should expect that it will not work or will cause instabilities. And it is pretty important to prepare for that, and also have a good collaboration with Microsoft if you have an enterprise agreement with them. And lastly, the last point, we're getting close to the end, to the last point and last demo, and that's about day 2 operations. And even if you do everything according to all the documentation, you follow all these checklists, things will fail in day 2. And I have also heard from other organizations, not only us, but others who went live and then things start failing, which kind of is a great illustration of that. Things will fail, but by doing all of these best practices, taking them into account during your day 0 planning, you will be more prepared to handle those issues efficiently, and start getting your heads dirty together with your operations team early on, and start by migrating some internal applications or less vulnerable applications to production first before you move the rest. And an amazing methodology that is available to simulate disruptions in your AKS clusters in order test and improve reliability of your system and resiliency of your applications is chaos engineering. And Microsoft has also their own Azure Chaos Studio, which allows you to run those chaos experiments, simulate disruptions, simulate outages, where you can test how long time it takes for the apps to get up and running, to an AKS cluster to be reconfigured, recreated. You could do that with help of these simulations. So really check it out. And check out the AKS Day 2 operations and AKS mission critical documentation, because there are a lot of useful insights there for Day 2 operations. And last advice is to avoid being the only expert that everyone runs to. There are quite many good memes about that one. But if your operations team is not prepared, if they haven't been doing anything hands-on until Day 2 operations, then they will be running back to you, and you may end up sitting with debugging and fixing those issues, and you do not want that. One AKS cluster is fine. If you have, maybe fine, it depends. But if you have multiple clusters and it's only you, it is not scalable. So you need to ensure that you involve the others who will be working with it early on, and that you are not a single point of contact. So plan, and prepare. And last demo, I'm so sorry for running over time, but I just wanted to show you this cool chaos engineering tool called Kube Invaders, and how it can bring an application down. So I have this very irritating application. It actually has also an irritating sound, but I just will not turn it on. So I have only one replica of that one deployed. So I will enable like auto refresh to see what will happen. But let's just see chaos neon cat. We have just one replica of that one. So let's try to see what will happen if I try to simulate outages. So we will just have it here, and I will use a tool called Kube Invaders, which is real nice. You can, though it is based on Space Invaders game, so you can see aliens being pods, and you can also enable tests towards nodes. But we will not do that today. So what will happen if I start hitting it now and simulate disruptions? As you can see, I have only one replica, so having that application offline is extremely easy for me. And what you can see, it's going. Oh, it's actually coming up relatively quickly, but it's really struggling on being up. And as you can see, it has been terminating a lot of pods. So what we can try out, the last thing before I'll stop, is that we will try to increase the amount of replicas to 4 quickly. Let's see. And we'll be able to see that we have now 4 aliens up and running there, 4 pods. So we will see if it will become that easy to kind of take it down. And as you can see, it becomes much harder to do that. So with help of these tools and these experiments, you can actually test how long time it was actually able to get down, but you will actually be able to see and adjust and improve the state of your applications and your clusters with help of such chaos experiments. So I have been a bit over time. So rounding up now the whole story, summing up the considerations. So first of all, adopt AKS for the right reasons, for it bringing value to you and your users, your customers, your organization. do invest time and effort into the planning phase, into day 0. Start small, start building from the top and expand and add upon that with more configurations to make your AKS clusters production ready. No need to start with everything at once, but in the beginning, start and expand iteratively as you mature. And do involve others, do involve the whole organization so that you own this new technical platform together. It's extremely important because you would not want to end up sitting with it yourself. And do not underestimate security, because your customers will ask you to provide proof of being compliant with those frameworks for CIS Kubernetes security, benchmark security, for instance, or OWASP top 10 for containers. So start with it early on to not end up with fixing a lot when it's up and running in production. And be prepared for that things will fail, both on your side and vendor side. So do have a plan for how to handle that. And don't forget those resource limits. And once you have done all that, you can just go and take yourself a cup of coffee and enjoy a fully functional AKS cluster or clusters. A lot of documentation I have prepared for you. It's not even enough of this slide, or we will get, our brains will explode after this whole long session from me. So I have a QR code here for you where you will be taken to the GitHub repo where I have all the demo apps, instructions on how you can run it locally and do the same scenarios locally and play around with it, and also all the material that you can check out for more details. And if you have any questions, just reach out to me. I am happy to connect and talk to you and discuss all of this in more detail. And I'm so sorry for running a bit over time, but I hope that you found it useful.
Awesome.
All right. Thank you, Kristina.
A lot of information. I hope you're okay.
It is a lot of information, but I think it's actually, that's kind of per the case for these types of things. There's a lot of useful information there, and I'm really glad that you actually managed to get through it not that much over time.
I was really scared for that one, so it was a bit over time, but I hope you're not that angry with me for that.
No, it's perfectly fine.
Cool.
All right. Thank you, Kristina. We don't have any more questions to see. We basically, there's been a lot of chatter, but not really questions. A lot of me commenting on all the different applications you've been showing.
Yeah, and if you want to discuss something in detail of what I have specifically talked about, like how we did it in our project, do not hesitate to reach out. I am really happy to discuss it and also learn from others. Learning from the real life experience is so valuable.
Definitely agree with that. Awesome. And I guess with that, then we should end the stream. So thank you very much. And thanks everyone for watching, and we'll see you next time.
Yeah.
Thank you.
Bye.
Bye.